Okay, so this time I have really done it. So I want to show you the latest program that I wrote, and this one is really freaky. I'm going to show you the source code briefly, and then I'll show it in action, what it actually does. Now this is some C code that uses the Allegro library. I dug up some years old Allegro source code that I wrote a long time ago. I've also done stuff using SDL, but I'm learning Allegro currently. So I've included all the necessary headers from both the C standard library and the Allegro library, as well as one that I wrote. And here I have several variables that define the width, the height, the variable for the display, all kinds of variables. There's tons and tons of stuff here. So actually, you know what? I'm going to show you what my program actually does. So I'm going to type make, and it should work. You see what we have here? We have a window. It says this is a spinning polygon by Chastity White Rose. So we have an 8-sided polygon. Well, it's actually more sides than that. It's a 8-pointed star polygon using a step of 3. I am able to change the type of polygon this is by editing the source code, and I will show you how that works. Now if I click the X, the program disappears, and you'll see why that is very soon. So these are the variables defining the polygon: its radius, its rotation and radians, all kinds of stuff. And this is all code initializing the library. You have to initialize the main library, the keyboard driver, the event queue, all sorts of crazy stuff. All this this crazy code that is all defined, and it's really ugly looking too. But then you can see this is the function that sets what the title of the window will be, and this is the function here that creates the window of that width and height. And of course all of these other things are, like if it failed for whatever reason to create a display, it will print an error message, all of that stuff. And then it has to register event sources and all that crazy stuff. And now this while loop thing here. See, there's a variable named loop. If you look up here, there's a variable named loop, and that variable is 1. And anything that's not 0 is considered true in the C programming language. Anything that's 0 is false. So while it's 1, or while it's true, while this loop will continue. Now this is the stuff that happens in this main loop. Now it clears to a certain color. In this case it clears to black, because 0 red, 0 green, and 0 blue. And then this is a function AL star polygon. And this is a function I wrote. I will show you the source code of this as well. I have a whole header file, and this is what I wrote. This is the biggest portion of the code right here. This code, it has global variables for the x and y points, their floating point, and there's the number pi. And then here is the function copied from my BBM library that obtains what the points for the polygon are going to be, the x and y, and then stores them in the x and y arrays, basically. And then this is the one that it has a whole bunch of stuff. It takes the width and height of the image, and let's see. Wait, this comment is not very accurate. That was from my old library. I removed a lot of the code, but the original code is still in my regular C BBM library, so I didn't modify the original. This is a copy. But anyway, I'll tell you what it does instead of reading the comment. It takes the width and height of the image. The CX and CY variables are the center of it. Center X, center Y, the radius, how big it is, radians, its rotation, the number of points it has, and the step is how it steps through those points. And I'll explain that one later if I have time. It's a very small function. It calls the other function, it has these variables, and it calls the polypoints function here to get the points of a regular polygon using that criteria. And then it loops through them. And what it does during each part of the loop is it steps through the points of those x and y arrays, and it draws a filled triangle. It does that number of times. So in this case, it's actually drawing 8 triangles to make that 8-pointed star. It's very strange, and it may not make very much sense. Geometrically, I would probably have to use an Inkscape model drawing to show you exactly what it does. But anyway, this is the code I wrote. It took me probably 2 or 3 hours to write this just the way I wanted. I copied some of it from my old code, from my BBM library, but then I modified it to work with Allegro. So I'm going to show you a few examples of how I can change this. And also this is that determines how it changes rotation each time. And this simply refreshes the screen. AL flip display refreshes the screen. So now you've already seen, I will show you one more time what it looks like currently. And then it's an 8-pointed star like that, but I can make it be simply a regular octagon. If I set the step to 1 instead of 3, I can then remake it, and now it's a simple regular plain old octagon. And just for the sake of showing you how I can modify every aspect of this, let's make this octagon red. So if I want to change the octagon to being red, all I need to do is change a few things. I'll change these numbers that are 255 to 0. Basically, I can use any color that exists in computers, but in this case, we're going to do all of red and 0 of green and blue. So now we have a red octagon that's spinning. But I will show you another one of my common favorite shapes, the 5-pointed star. Well, actually, first, let's change the number of points to be 5. Okay? So if I change the number of points to be 5, we have a, let's see, it's compiles and runs it. So now we have a spinning red pentagon. But I can change the step to 2, and it changes how it steps through the points. And then what we will have a spinning red pentagram, the 5-pointed star. And there's more. I can even change which way it spins. You saw it was spinning clockwise. Well, if I change this from a plus sign to a minus sign, then it will change the angle of its rotation. So now it spins counterclockwise. So I can make it spin clockwise, counterclockwise. I can even change the size of it very easily. So let's say I wanted to make it smaller. I currently have a fraction 7 out of 16. Let's make it 3 out of 16. Okay, let's see what happens here. Now it's a smaller spinning pentagram. And now what happens if I do it 8 out of 16? It might actually be too big, because that's the radius, not the diameter. Oh, it just barely fits in there. It's crazy. I'm gonna switch this back to 7, and I wonder what happens if I make the step 3. I'm not entirely sure if it'll work or if it will fail exactly. It gives us the exact same shape. But yeah, I mean, I can do all kinds of incredible things. So let's say if I wanted to change it to a 15-pointed polygon with a step of 3. Let's see what it does. Whoa, freaky. Yeah, it's pretty crazy. Okay, let's change this number to 7. See, this is crazy. And also, while I'm at it, I'm going to change this back to a plus sign, and then I'm going to, I will simply delete that part, and then 0, comma, so wait, oh yeah, okay, it'll be green now. So now we're going to make this shape green. Yeah, so now we have a spinning green star thingy. This is absolutely crazy. So basically this is what I'm capable of doing now. And see, it's actually very small when you think about it. And I press escape, the program ends. And why does it work when I click the X or press escape? Well, here it's very simple. Now these 4 lines are everything that happens during the loop. Each time it clears the screen to a very specific color, draws a polygon, changes the rotation of the polygon, then refreshes the display. And then it does this event checking routine here. So it checks the next event and it continues if no event was found. And this, yeah, so you see if the event type is that a key was pressed down, and then it checks to see if it was the escape key. And if the escape key was pressed, it changes the loop to 0. And if the event was display closed, because I clicked the X, it also sets the loop to 0. So either way it ends. So it's very interesting. So anyway, I think what I'm going to do is I'm going to set this back to, I'm going to set this color back to white. I usually stick with black and white. And let's for example, let's make this a step of 1 and a number of points of 6. This should give us our regular hexagon. It takes a little bit of time to compile because every time I do it I am recompiling the program, so it's freaky, but hey, it's beautiful. Now you may wonder, why did I go to all the trouble to create this all new code? Well, quite simply because my usual method, although it's beautiful, and I've uploaded many animations to Facebook and Twitter and stuff like that, it takes a long time to do because it creates a series of image files and then I have to turn them into a GIF animation. And I've made previous videos on how I did that. But now what's neat about this here is that technically it's all by this source code. So I have about 5 kilobytes of source code, and it's not actually creating any variables. It's simply defining a whole bunch of variables, setting up this library, creating a display, and going through a loop where it just creates the same animation, changing it over time. And just to show you, there's only one portion of code that I haven't shown yet, although it would take me forever. I still don't feel like I've explained the entire process of everything, but this is only 5 kilobytes of code and there is so much to explore in this. This is nothing compared to my BBM library. This is still very basic, but I'm very proud of what I've done here. But there's one portion of code I have not explained yet here. Now this ALRest function, this is resting for this many seconds. So it's a floating point, so it's actually less than a second that it's resting. So I'm going to comment out the rest function. And you notice every time I do make, it's actually running the command which compiles and runs it with GCC. See how fast it's spinning now? That's because before I had the wait function which was pausing a certain number of milliseconds basically. But now that it's not pausing, it's running it as fast as my computer is capable of running it. Now keep in mind, this is by no means the fastest of computers. This was bought in 2012 and it's too slow to run Minecraft at decent speed. But boy, can it spin a polygon. So yeah. So that's the thing, is I'm going to put this back the way it was because I chose that specific number just because I really liked the speed at which it spins. It's not too fast, not too slow, it's just right. So I'm very proud of that, and it's actually a lot. So yeah, I mean, there's so much here. Explaining how it uses the formula with sine and cosine to get the points, that's complicated. However, you know, I want to show you one more thing. There's always so much to show you. Now that spinning polygon was done with only 2 source files, but I want to show you here. This is my main BBM library that I usually use to make animations and that kind of thing. And look at all the source files. Now, not all of them have to be used at any given time, but this is my main, like I have so many files here, my source files here, and that's 132 kilobytes. So that's an example of how much code I wrote in my main BBM library. But anyway, back to the Allegro one. Now, this has a make file, and that's why when I type make, it does this command. It's actually doing this command. It includes the library for Allegro and the library for Allegro primitives, which is a subsection of the library, and includes triangles, which basically my thing just creates a series of triangles to construct bigger polygons. So anyway, it's very beautiful how it works. And in the future, I've thought about even combining it with other things, such as I thought of combining it with my other code, which saves image files. So it could not only display it to the screen, but also save it as image files. However, since I already have that on my other project, I see no need to copy all of that code. But anyway, that's basically it for this video. You got to see this amazing polygon. Actually, there's just one little thing. Now, when I click the main.exe file, it's looking for certain DLL files and it can't find them. Now, so that's the thing. So it works when I'm in the terminal here and it has the spinning star. And I can also, I can just do main like this and it runs it. However, what I need to do is I need to get this this file to run when a user simply double clicks it. And here's how I'm going to do it. So I'm in a little Linux emulator. I'm technically using MSys2. I'm going to echo the path variable. Now this will give me a clue as to where it's getting the DLL files. This is what I'm looking for. So, okay, so what I'm going to do here, I'm going to open a new tab here. I'm going to go to my MSys thing here, and I need to find the specific DLL files. So let's look at what was the DLL file. Yeah, Allegro 52.dll and the primitives. Okay. So that's why it's showing me those errors. Let me take a look at those errors again. Yep, this is the missing DLL file errors. It's needing those 2 DLL files. So let's go to the bin folder. I have a feeling that, ooh, wait a minute. Ooh, check this out. So because of the fact that Allegro starts with the letter A, and this is sort of alphabetical, the ones that I need, Allegro 5.2.dll and the primitives, are both here. So because they're not in my path by default in Windows, I will copy them to this folder. Now when I click the main.exe file, what in the world does this mean? The procedure entry point GXX personality V0 cannot be located in the dynamic library. What does this mean? Huh? I don't know why it's giving me that error. That's actually very, very bizarre. Huh. Why is it giving me that error? That is so weird, because I don't know. I don't know why it's giving me that error, because it should work the same double clicking it as it does in the command line here. So I have some more work to figure out why it's doing that. But anyway, you see what the program does, so I'll probably finish working out the bugs of it in the future. Anyway, I hope somebody has learned something from watching this programming video. Thanks for watching.